So another way we can solve systems of equations is by this substitution. Okay. So let's get out that note sheet and look at number 1. And it says y is equal to 3x and x plus 2y is equal to negative 21. Those are your two systems there. Okay. So you want to solve for an x and a y that makes this true and that makes this true. Okay. So let's just look at a separate problem here. You don't have to write this one down on your note sheet. If I told you x is equal to 5, and then what is 10x simplified to, what would you say? 50, right? Because you just plug in x is 5, right? You've been using substitution for a long time. Whenever you know something is equal to something else, you can substitute it in for x, right? So x is equal to 5. You substitute that in for x, and 10 times 5 is 50. Okay? Solving by substitution is very similar, except you usually just have bigger things to substitute. So I know that y is equal to 3x, right? That's what this part of the problem is telling me. So since y is equal to 3x, I can replace y in the other equation with 3x. And then I can simplify to solve for x. So in the other equation, I'm going to write x plus, and in place of y, I'm going to put what it's equal to, which is 3x. And I'm going to rewrite everything else the exact same way. Now, one important thing to remember is every time you substitute into another equation, you have to put it in parentheses, always. Okay? It's going to help you keep track of negatives, remember multiplication, if there's exponents. Every time you substitute, you have to put it in parentheses. So all I did was I substituted for y. In place of y, I put what it's equal to. I put 3x. And then we can simplify this equation to solve for x. I have addition and I have multiplication, so I'm going to do the multiplication first. 2 times 3x is 6x. I always combine any like terms I have that are on the same side of the equal sign. 1x plus 6x will be 7x. And then what do I have to do to get x by itself here? Divide by 7, right? Undo that multiplication. So 21 divided by 7 is 3. Negative divided by positive is negative. So x is negative 3. I substituted, I simplified, and I found out what x is. So the only other thing you need to do here is find out what y is, and that's very simple because you can just take x and plug it in now to find out what y is. Y is equal to 3 times negative 3, because that's what x is. So y will be negative 9. So you can write your answer like this, or you can write it as an ordered pair like we did with the graphs. You could write it like this also. Either way will work. Because you could have solved this one by graphing, right? This is in slope-intercept form. You would have went to 0 on the y-axis, went up 3 over 1 and graphed it. This one you would have had to put into slope-intercept form. You would have had to move the x over, then divide everything by 2. And they would have intersected at negative 3, negative 9. But substitution was a better way to solve this problem because I wouldn't have had a fractional y-intercept. Makes sense? That's why substitute. Yes, question?
So like the x plus 6x, it's just like 1. So.
Yeah, exactly. It's just 1x plus 6x, so I got 7x. Right, good. Yep. Other questions on that one? And I substituted there. All right, so try number 2 yourself, and we'll check it here together. So before you start any substitution problem, you always want to look at which variable is already solved for, if there is one. Which variable is already by itself. And in this case, it's x, right? X is equal to 5y. So since I know what x is equal to, I can replace it in the other equation with 5y, with what it's equal to. And every time you substitute, it's got to go in parentheses. So that equation is going to look like 2y plus 3. I'm going to replace x with what it's equal to, which is 5y, equals 34. And then you just start simplifying here. You have multiplication here, and you have addition here, so you need to do the multiplication first. 3 times 5y is 15y. And then you have like terms, 2y plus 15y is 17y equals 34. And finally, you undo the multiplication by 17. You divide both sides by 17, and you get y is 2. We get that one? So y is 2. So now that you have that, you need to find what x is equal to. And you can either plug in y here or here to find x. It's going to be a lot easier to plug it into this one, though, right? Because x is already solved for.
Isn't it supposed to be 32?
Yeah, but that was a typo. Change that to 34. Yeah, just because you would have got a fraction here, which is possible, but I didn't mean for that to happen. I wanted that to be 34. Yeah. So now you know x is equal to 5 times whatever y is. That's what this problem says. So x is equal to 5 times 2. Then x is equal to 10. So you can write it like that, or as an ordered pair like that. Either way is appropriate. Any questions with that? Substitution. A little bit easier than graphing, but there are probably maybe a few more places you could make a mistake. But this would have took a long time to graph these, right? Would have to put that slope-intercept form, would have to put that slope-intercept form, and then start graphing. Okay. All right, let's look at 3. Which variable is already solved for here, x or y? X, right? I know x is equal to y minus 1. So I'm going to replace x in the other problem with what it's equal to, y minus 1. That way I get an equation with just one variable in it, just y's. Because equations with 2 variables I can't solve by itself. So I'm going to replace x in the other equation with y minus 1 and rewrite everything else the same. So that's what I did there. Now I have an equation with just y's in it, and I can solve that. First thing, I need to get rid of those parentheses, so I'll distribute that 4. 4 times y is 4y. 4 times negative 1 is negative 4. Equals 3y plus 3. Then I need to get the y's on the same side of the equal sign, because these aren't like terms, these aren't like terms, so I can't combine those. I need to get the y's on the same side. So I can move this over here, or I can move this over here. I want to move the y over that's going to keep it positive. So should you subtract 4y from both sides, or should you subtract 3y from both sides to keep it positive? I do the 3y, right? Because then that's going to go away, and that's going to make that positive 1y. I still have minus 4, and I still have 3. I've subtracted 3y. You could subtract 4y from both sides, but then you're dealing with negative y's, and I don't want to deal with that. Then finally, get y by itself, undo the subtraction by 4, and add 4, and y is 7. Now that you know what y is equal to, it's very easy to solve for x. Take it and plug it in. X is equal to 7 minus 1, because I knew y was 7, so x is 6, and there's my solutions. Now, the nice thing about these problems, when you have to do quizzes and test over them, if you want to make sure you get 100% on the next quiz or test, it'd be very easy to do so. Because all you'd have to do is plug in 6 and 7 to this equation, and plug in 6 and 7 to this equation. And if they were both true, then you know you're right. If only one of them was true, you're probably wrong somewhere, or you made a mistake. Or if none of them were true. For example, if I plug in x is 6 and y is 7, I get 6 equals 7 minus 1. That part's true. If I plug in 6 here, that's 24. If I plug in 7 here, that's 21 plus 3, which is also 24, so I'm right. I'm looking for an x and y that make both of them true. So it's very easy to check your answers on these. I'm not going to make you do that on these, but you can if you get something that looks weird. Okay? All right. Try number 4 yourself here, and we'll check it together. Here on number 4, which variable is already solved for? Y, right? You know y is equal to 3x minus 15, so that's the variable you're going to replace in the other equation. You're going to substitute for that variable because you know what it's equal to. So your first step should look like this. 4x plus 5, and in place of y, you put 3x minus 15. Equals 11. So now I have an equation with just x's, which is good. I just need to simplify this to solve for x. I'm going to distribute to get rid of the parentheses. 4x plus 5 times 3x is 15x. 5 times negative 15, negative 65. I messed that up. That's 13. I wrote 15, didn't I? Yeah, sorry, that should be 13. I just wrote the problem down wrong. That's 13, which makes that 13. So then when you distribute that 5 there, then you should get minus 65. Yeah. Combine like terms. What are my like terms that are on the left side of the equal sign there? Good. 4x and 15x, so it says just add. 4x plus 15x is 19x. Then I just need to solve for x here, so I'll move that minus 65 to the other side by adding it. That leaves me 19x equals 76. And then divide both sides by 19. That should be 4. So x is 4. We get that part? Good. And then we're going to take that x, and we can find out what y is by just plugging it in. So y is equal to 3 times 4 minus 13. 3 times 4 is 12. 12 minus 13 is negative 1. And there's my solution, 4, negative 1. If you had to graph these, this one's already in slope-intercept form, right? But it would have been a little bit bigger graph because its y-intercept is negative 13. Right? This one you'd have to do a lot of work to put it in slope-intercept form. So that's why substitution is probably a better way to solve this problem than graphing would have been. Even though if you would have graphed it, there's where they would have intersected, 4, negative 1. All right, there's one solution to this problem at 4, negative 1. If you want to be really sure, plug in x and y here, plug in x and y here, and make sure they're both true. Questions with that? I think we're doing pretty good with that, just walking around and looking. So what's the difference in this problem and the previous ones we've just done?
X and Y should be correct.
Yeah, none of the variables are solved for, right? There's no x equals or y equals anywhere. The x's and y's are on the same side. So you need to get one of the variables solved for before you substitute. Because I can't substitute for x and y here without knowing what it's equal to over here, or vice versa. So of these 4 variables, which one would probably be the easiest to get by itself on one side of the equal sign? This 1x is minus 3y, this 5x is minus 2y.
First one.
I would say that would probably be the easiest to get by itself, right? Because there's just a 1 in front of it, which is what we want. How am I going to get that 1x by itself? How do I move this to the other side? Yeah, add 3y, right? That's all I have to do. Add 3y here, that's going to go away, and then I have to do the same thing on the other side of the equal sign. So this equation is going to become x equals negative 9 plus 3y. Now I have a variable that's solved for that I can substitute. I know what x is equal to. Since x is equal to negative 9 plus 3y, that's what I'm going to substitute for in here. In place of x, I'm going to put negative 9 plus 3y. So I got 5. Always has to go in parentheses. Minus 2y equals 7. Distribute to get rid of the parentheses. Negative 45 because you're multiplying, plus 15y minus 2y equals 7. I'm just rewriting everything else each step. What are my like terms there? On the left side of the equal sign?
15.
Yep, 15y and minus 2y, right? 15y minus 2y is 13y. How do you move the negative 45 over? Add it, good. So now I have 13y equals 52. And then finally undo the multiplication by 13 by dividing both sides by 13. Y equals 4. So y is 4. The hardest part's done because once you have one, it's very easy to find the other one. You just take it, you plug it into the equation that's solved for. So x is equal to negative 9 plus 3 times 4. Now, probably the mistake a lot of people make here is they do negative 9 plus 3. But order of operations says you have to do multiplication before you do addition, right? So it should be negative 9 plus 12, which is going to be 3. So the solution there is 3, 4, which again, you could write it like that if you wanted to. Any questions with that one? So we had to get one variable by itself first. And you could have got it, technically you could get any of these variables by themselves. It would just require more work to get the other ones by themselves. I'm going to do the one that's easiest. I could have got this x by itself. I could have added the 2y over, then divided everything by 5. Then I would have had fractions. And just would have did more work than I had to do. Okay. So there's actually 2 of them here that would be about the same difficulty here. Which variable would be easy to get by itself? That x would be pretty easy, right? Also, what else would be pretty easy to get by itself? That y, right? So you could do it either way would work. Let's say I'm going to get this x by itself just because it came first. So I'm going to move that minus 5y to the other side by adding 5y. If you got the y by itself on the other side, you'll still get the same answer. So this is equal to x. X equals 2 plus 5y. Again, you can't add those, are not like terms. So since I know what x is equal to, that's what I'm going to substitute for in the other equation with what it's equal to. And every time you substitute, it's got to go in parentheses. So 2 plus 5y, and for x. Then I still have the plus y equals 4. Distribute to get rid of the parentheses. 4 plus 10y plus 1y equals 4. Combining like terms if I have them, which I do, 10y plus 1y is 11y. Then I need to get the 4 on the other side of the equal sign. I'm trying to get y by itself, so I'll subtract 4 on both sides. That gives me 11y equals 0. And then finally, I will divide both sides by 11. And 0 divided by anything is 0. So y equals 0. Should be one answer. You know what y is, so plug it in to find x. X is going to be equal to 2 plus 5 times 0. Again, make sure here, and this probably really wouldn't matter, but 5 times 0 is 0. Well, it would matter, I'm sorry. So you get 2 plus 0. You have to do the multiplication first. So x is 2. So the solution, x is 2, y is 0. So if you got something different and you're not sure where you went wrong, let me check it. I'll look for it. We should have x is 2, y is 0. And again, you can double check your answer. If you plug in x is 2, y is 0, that'll be 4 plus 0, which is 4. That one would work. If x is 2, y is 0, that'd be 2 minus 0, which is 2. That one would work, so that's true.